Hey everybody. Today I'm looking at age gaps in Hollywood movies and trying to answer a question first posed in the February 14th, 2023 Tidy Tuesday Challenge. I've got it highlighted here. Is there any correlation between the results of the Bechdel test, which I'll talk about in a minute, and the age gaps that we're seeing in this data set? So by the end of this video, I'll have a bit of an answer to that question. For those that don't know, every week Tidy Tuesday presents a new, usually very interesting data set that we can use to practice data wrangling, cleaning, visualization, modeling, really whatever we like. The Hollywood age gaps data set comes by another one of my favorite data sites, Data is Plural, which you should check out. Lots more good data sets for practice there. The Bechdel test data set comes from a couple years earlier, back in 2021, March 9th to be specific, and this looked at movies from a slightly different perspective, asking whether and sort of how well they passed or failed the Bechdel test. And in case you're not aware, the Bechdel test is a famous test that you can apply to movies. It gives you one kind of very rough standard for gender inclusivity there. According to Alison Bechdel, in an old comic strip, Dykes to Watch Out For, you can evaluate a Hollywood movie based on whether it has two women characters that have names, whether they have a conversation with one another, and whether that conversation involves something other than a man. And if all three of those things are true, it's said to pass the Bechdel test. And to weaken that a little bit, you can say sort of on a scale of 0 to 3, how well is it doing? Does it have two named female characters? Do they have a conversation with each other? Is it about something that's not just a male interest? Okay, so what I want to do is to get both of these data sets and start looking at the correlation between these two variables. So here I am in R. I've already loaded up Tidyverse, as usual when I'm doing data analysis, and set the theme to minimal. I prefer that to the one with the gray panel background. I have loaded up the age gaps and Bechdel data sets using code copied and pasted directly from Tidy Tuesday. So for instance, the age gap set you can see right here in the Get the Data Here section. You certainly have other choices for getting it. One comment on this, I have downloaded the Bechdel raw dataset using this piece of code right here rather than the movies dataset. This omits information about like ticket sales, box office information, things like that, but it has more observations and it does have the outcome of the Bechdel test, which is all I'm really going to need here. All right, so let's get oriented here a little bit. We can take a look at the Bechdel set and then get a visualization for the variable from that set that we're going to be interested in. I guess I didn't hit Command-Enter on those commands. Okay, great. So the Bechdel set here has 8,839 entries. You can see that each one is a movie. We have an ID number and an IMDb ID number, as well as the year that it came out, the title of the movie, and the rating. So this is the rating on a Bechdel test scale. So 0 means that it does not have two women characters that have names. A 1, if I can find one here, there it is, means that there are two women characters that have names, but they don't have a conversation with one another. A 2 means that they did have a conversation with one another, but that it's about a man. And a 3, like right here, is going to mean that the two did have a conversation that was not just about a man. So that's what that scale is referring to. By the way, although these are numbers, this is actually kind of categorical data. I don't know that it makes sense to really subtract or take averages here. So we'll have to think about whether we want to deal with this, exactly how we want to deal with this, once we get to our visualization and modeling section a little bit. What the best way to treat this as, whether when it's going to be okay to just take it as a number, and when we need to think about it as an ordinal categorical factor. Okay, so let's get just a simple bar chart for the ratings. Like, are we getting a lot of zeros, a lot of ones? What's the deal here? So certainly not a fancy plot. You can see that a fairly substantial majority of movies in this set fully pass the Bechdel test with a 3 on this scale. Now let's look at age gaps. So here we only have 1,155 movies, in contrast to the Bechdel set, which has 8,839. So obviously, these don't all match up one-to-one. There's going to be some in each data set that are not in the other. In here, we have all of the different names of the movies, some information about them, the age difference, which by the way is always positive, the names of the two actors in question, and what their genders were. So what they've done is they've taken the older actor and subtracted from their age the age of the younger actor. So that's what we're getting here. Notice, by the way, that some of these movies are going to be represented more than once. There's a hint at that with a couple number here, because of course, many, many movies have more than one couple. So we will have a number of rows here for some of these different movies. We'll have to take that into consideration as we go along. So let's get a plot for those age differences. All right. So in this histogram, which I will zoom in on, we can confirm that, in fact, the age difference is always positive. It's never negative, never less than 0. So this is reflecting the fact that they're taking the older person's age minus the younger person's age. The older actor's age minus the younger actor's age. And we can see that there's a number of zeros, and it goes all the way up into the high 50s. Interesting in its own right. Now, that's potentially very interesting, but I'm actually not just interested in the raw difference in the ages. And the reason is because I want to relate this to the Bechdel test. And so I'm thinking about sort of gender parity in movies. So I'm not just interested in, are there big age gaps? I'm interested in, is there a big age gap, man minus woman? Are the men in these movies typically older? And I might hypothesize that in movies that have a larger age gap, we're less likely to pass the Bechdel test, because if the movie's having one gender, I guess we could say problem, inequity, that maybe we would also expect to see it pointing in the same direction on this other scale. Okay, so this next bit of code right here is going to add a new variable to the age gaps data set. So what I'm doing is I'm taking the age gaps data set that I've had and using mutate to add a new variable. It's going to be called man older. And the way I'm going to do that, and there's many, many different ways to do this, is to say, okay, if the first character, if character 1 is a man and character 2 is a woman, then subtract their respective ages. And if character 2 is a man and character 1 is a woman, do the subtraction the other way around. So this is just a slightly long-winded way of saying, take the man's age, subtract the woman's age. So let's get another histogram here. We'll zoom in on that. And we can see that now we do have a data set that includes both positive and negative values for this man older variable. Although most of the observations are still positive, indicating that when we have love interests in Hollywood movies, the man does tend to be older, sometimes substantially so. Let's go ahead and get the average on this while we're at it. Let's just see kind of how bad it is overall. So I am going to take the age gaps data set and the man older variable. And I'm going to notice that there are some NAs. I intentionally wanted to point this out because although there are no NAs for the age gap for the age difference in the age gaps data set, I've introduced some here with my case when, simply because I've only allowed for 2 situations here, where character 1 is a man and character 2 is a woman, and where that's reversed. So when I've done that, I have ignored same-sex couples, which normally I don't like to do, but in this case I think it's actually appropriate because I'm looking at age gaps between male and female characters. So it's a little bit the point. So I'm going to drop those from my data set, these NAs from my data set in a little bit. For now on, let's just put an NA.rm equals true to get this mean. Okay, so on average, men in these movies, the actors playing the men in these movies, are about 8.5 years older than the women that are playing the love interests, playing the female love interests in these movies. Now, ultimately, in this analysis, I'm interested in how this age gap, the man older variable, relates to the Bechdel test rating, the 0, 1, 2, or 3. So I need to combine these two data sets into just one. And I'm going to do that using left join. So left join is going to take one data set, I sometimes call it the target data set, in this case I'll use age gaps, and mutate it, in other words, add new columns from another data set, in this case Bechdel. So what I'd like to do is to take age gaps, and for each of the movies in here that are represented in the Bechdel data set, I would like to be able to have the rating variable sort of mutated on. So things get a little bit complicated because movie name is how the name of the movie is encoded in the age gap set, but in the Bechdel set, it's called title. Additionally, movie name, or to say it differently, title, isn't really enough to identify an individual observation in these sets because sometimes movies are remade with the same title, sometimes the same title is recycled among very different movies. So I have taken the age gap set, left joined it with the Bechdel set, and using the by argument to specify the ID columns, the ones used to match up observations between the two data sets, I'm specifying two different pairs of columns. I'm saying match them up by the movie title, which is called movie name in the age gap set and title in the second, and also the year of release. So release year in the age gap set, which is equivalent to year in the Bechdel set. And when I execute this, I'm going to get a warning, and I've intentionally not resolved this warning in advance because I want to show it and talk about it a little bit. Warning, in this command detected an unexpected many-to-many relationship between X and Y, which means these two data sets. When it says X, it's referring to age gaps, and when this comment refers to Y, it's talking about the Bechdel set, so X and Y. Now, I was expecting this part. I was expecting some of the Y matches to have multiple rows in X. I expect some of the movies in the Bechdel set to have multiple rows in the age gap set because, as I pointed out, some of these movies have more than one romantic couple and therefore have more than one age gap represented. What's surprising to me is that there is a situation where we have one age gap but multiple results in the Bechdel set. And that's happening in row 810. So I want to take a second and just kind of look and see what that is. And it's Wonder Woman. So I looked at the age gaps data set, just looked at the movie name variable and took the 810th entry as advertised and got Wonder Woman. It turns out that Wonder Woman 2017 has 3 Bechdel ratings. And we can see that just by doing a filter on the original Bechdel data set using the title that we just saw, Wonder Woman. There's actually 4 rows here, but one of them is a 2009 version. So I'm just going to go ahead and take those out. I'm going to take the movies data set that I have here and just take out the observations that have this ID. And by the way, I've checked to see that each ID in this data set really is unique to each row, so I'm not losing additional information here. This, of course, raises the question, though, are there other duplicates, movies that are duplicated here? Now, based on the output of this join, I don't expect any of these to be problematic, but in a really thorough analysis, I'd want to take these into account a little bit more carefully. So I'm just going to take the Bechdel data set, so going back to that original Bechdel test data set, and count how many observations I have for each combination of title and year, and then only keep the observations, the movies, that have more than one. So for each combination of title and year, show me if that happened more than once. And it turns out that there are 8 rows in this data set, ranging from all the way back in, 1931 to just a few years ago, Wonder Woman, and we can see some duplicates here. I'm not going to do anything else with those, but it's an interesting phenomenon. One interesting sort of data wrangling challenge is to go back to the Bechdel data set and drop the duplicates. In other words, only keep the first time that one of these movies shows up and not subsequent ones. I may do that in a future video, but not today. All right, so let's get a visualization. This isn't going to be as elaborate as some of the ones that you'll see from Tidy Tuesday. I'm not a data visualization specialist, but I'd like to get this looking kind of nice. So in order to do this, I am going to, first of all, get a categorical variable corresponding to rating. So I know rating is 0, 1, 2, and 3. Currently in R, those are being treated as doubles, as numbers, but for many purposes, including one that we'll use in just a moment, it's good to have that as a categorical variable. I am also going to drop some NAs. I'm going to drop rows whenever man older is an NA, and remember that happens exactly when we have a same-sex couple, which just isn't my focus here because I want to think about gender inequities. And I'm also going to drop NAs for the rating variable. And these have come in when we did the join, because not every movie in the age gaps data set has a match in the Bechdel data set. Okay, so let's do that. And now let's get my ggplot. So what I'm going to do is I'm going to put the categorical version of the rating on the x-axis, and then the age gap, the number of years by which the man is older, on the vertical axis. And since I have one categorical and one quantitative variable, I'm going to do a box plot. I like box plots, but the downside of them is that they only display summary information. You don't see individual observations. So I'm also going to do a geom jitter, and this will give me a sense for sort of what the sample sizes are in these different categories. Since I'm plotting individual observations here, I'm not going to double plot the outliers. Both geom box plot and geom jitter will plot a point for an outlier, so I'm going to take that out. I'm going to change the labels on my x-axis. Rating cat is still 0, 1, 2, or 3. I would like 0 to be fail, 1 to be that there aren't 2 women, 2 to be that they don't have a conversation, and 3 to be that they only talk about a man. Finally, some nice labels. I'm kind of proud of the title, Something to Talk About, from an old Bonnie Raitt song. Let's see what this looks like. See if it kind of matches up with that hypothesis that I mentioned earlier, that probably bigger age gaps would indicate that we're less likely to pass the Bechdel test, or to pass it less robustly. This plot seems to give some evidence against that, however. It sure looks like there aren't radical differences in the male age gap between the different levels of passing and failing the Bechdel test. If you kind of squint hard and put your hand over the fail box and just look at the 3 boxes on the right, there does seem to be a somewhat of a downward trend. So as the movies are sort of doing a little better on passing the Bechdel test, they do seem to have a little bit less of a male age gap, but it's pretty small. So let's quantify all of this a little bit more. The first thing I'll do is to answer the literal question that was answered back in this Tidy Tuesday challenge that I started with, going back to the Hollywood age gap data set. Where is it? Right there. They use the word correlation. Is there a correlation? So let's actually do the correlation. So now I'm going to use the non-categorical version of the rating variable. I want to do a correlation, so I want to treat that as numerical. And there's a slight negative correlation. So as the age gap gets greater in the direction of the older man, the rating on the Bechdel test tends to go down slightly. Not too surprising there, but the correlation is certainly not strong. Now, I mentioned earlier about how the rating isn't truly a quantitative variable. It's actually an ordinal categorical. And so we might be concerned that just doing a correlation here isn't completely appropriate. So I'm also going to run a correlation that is fully appropriate, namely the Spearman correlation. And what this is doing is essentially calculating a correlation between the quantitative variable and then the categorical variable, just looking at the ranks of the corresponding quantitative variable. I owe you a video all about Spearman correlation at some point. Suffice it to say that it's a version of correlation that is intended for categorical ordinal data. And when we do this, we get negative 0.151. So slightly different, but not radically so. And to be honest, these two forms of correlation tend to agree fairly closely. There's certainly exceptions to that, but those exceptions tend to be the sorts of things that are built to be exceptions. The last thing I want to do here is kind of think about this from a modeling and ANOVA perspective. So let's get a linear model. Let's predict whether the degree to which the man is older using the categorical version of the Bechdel test rating. Obviously, we're in the same data set that we've been using for a little bit, data equals movies. And let's get the summary on this. So this is a linear regression model just using one categorical variable. Zoom in on this a little bit so that we can see it well enough. There we go. Okay, so there's a couple things that we might look at here as we make a decision. The first is the overall p-value from the model that's gotten using an ANOVA. In particular, if the rating category was not informative about the age gap, we would still get data like this about 0.02% of the time. So not frequently at all, but not statistically impossible either. So it's not as radical a p-value as we often see in hypothesis testing. But it is still a significant one. In contrast, look at the p-values here for the actual the individual coefficients in our data set. So what we're seeing here is the sort of estimated age gap within the rating cat 0. So those are among movies that fully failed the Bechdel test. If we then go to rating category 1, we have a positive change on average of about 1.6 years. If we instead go from rating 0 to rating 2, we have an average change of negative 0.42 years. And if we go to rating category 3, we have an average difference change in the age gap by about 2.22 years. And all of that matches up with what you see on this box plot. Standard disclaimer, box plots are showing medians, not means, but the data is fairly symmetric, so you'll see the same trend here between the medians and the means. Notice that all of these p-values are non-significant. So this is saying that there's not statistically significant evidence of a difference in the age gaps between category 0 and category 1, category 0 and category 2, category 0 and category 3. With pretty high p-values. Now, I just summarized 3 statistical tests all at once. That's a little bit of a no-no because when you do 3 statistical inference tests, your probability of a type 1 error increases. Remember, this is a p-value for just one test. In a sense, we need to take all 3 of these into account. One of the ways we can do that is with a Tukey honest standard differences test, which will essentially penalize our p-values by taking into account the fact that we're doing multiple tests. An added benefit of that is that it will also test for differences between other categories. Right now, all of these p-values are in comparison with category 0. So category 0 versus 1, 0 versus 2, and 0 versus 3. A Tukey honest standard differences test will also compare 1 and 2, 1 and 3, and so on. So what I'm going to do is I'm going to replace LM with AOV to get an ANOVA model, which is just a linear model underneath the hood, but it's going to allow me to use the Tukey HSD command on the model, and there we'll get those pairwise comparisons. So you can see that all of the p-values here are very big, except for the comparison between category 3 and category 1. So remember, those are the differences between, or those are the movies that fully passed the Bechdel test, rating category 3, and the movies that had 2 women with names that did not have a conversation with one another. Now, before I close, I want to point out a really important way in which I've done a little bit of a disservice to both these data sets, and that's that I haven't looked at any individual movies throughout my analysis. And this is unfortunate because there's tremendous variability within these movies. Some of the movies with the widest age gaps are actually addressing exactly that question, sometimes satirizing it, sometimes looking at it more seriously. Similarly, some of the movies that most egregiously fail the Bechdel test are movies that are carried by a single woman character, and there just aren't a lot of conversations or opportunities for conversation for that person in particular. If I were really doing a full analysis on this, I would want to highlight some points on this plot and think about them a little bit more in depth and use them as a basis for a larger conversation.